My name's Tui, and let's get back to Tui Time Graphics. Last week we uploaded 3D models, and now we are rendering all their vertices just like so. It's a spectacular sight to see. But this week we're going to go into how to optimize loading multiple of these objects at one time using instancing. So say I were to want to load this same armadillo just with different skins over and over and over again, maybe like 40 of them on the screen attacking your player on a game or anything, and we would have to load that 40 times in order to get every single one of them the same. So say we have a scene. See if I can so I made this, but I don't want to do that yet. So say we have a scene and we need to add 40 different guys. Let's just say like 5 different guys, right? And they all are made and scaled from that same armadillo. These are all armadillos, and say we want them all to appear. Okay, so this guy right here is probably made, like the armadillo is probably made of, like we can actually see this, but it's made of the armadillo. So if we go click on him and stop it, so it's already kind of running slow, so imagine loading a bunch of them. But there's got to be a way to, I think, isn't there? Right here. Boom. Nowhere to select them. There we go. Okay. One of these options will tell me how many vertices he has, I think. Right here. So there's 106,000 vertices on this one guy. If we loaded 40 of these things, that would be, 106, that would be 400,000 vertices. No, that'd be like 4 million vertices because there are 40 of them. There'd be 4 million vertices that we have to keep track of and render. Why would we do that? There's no point in trying to keep track of that many vertices for multiple objects if we're going to use the same object over and over again. So as opposed to loading them up one by one and then just changing all the vertices for all the different objects, we can load one object, just use these vertices, and then use the model constants of 40 different, because there's not, the model constants not nearly as many bytes, so we can just kind of keep track of the model constants for the different instances. And so let's go over that right now. Let me see. So see, I didn't even use that. That was ridiculous. So I put together this right here. Let's look at this side first. I'm going to drag it over so you don't even look at the other side. So so you'll notice that this little picture diagram right here will represent memory on your computer space. And I know these little bytes aren't accurate at all, but they're just kind of to show a point of, let's use red. Yes. So this is the GPU. This is memory on your GPU. Say we wanted to load a model, right? Where we're using StageN, so it's a per vertex qualifier. So we go vertex by vertex by vertex for all 40 different objects. Well, we'd have to load the object right here. So this right here would be the one object. Here are their scene constants. And then here are the model constants, just like normal, right? And then we'd also have to, so the scene constants will always stay the same. We pass those in once, and then they'll always stay the same until we we'll pass them in every single time, but we don't draw with that. We draw the vertices. And you see we have, now we'll go a second time loading another set of vertices, and the vertex model constants for that. So instead of drawing, uploading both of these full models, let's get rid of one and just use the vertex model constants. You see that? For every single one, because those are what does the rotations and the transformations and the putting in the world. We can just reuse the vertices that are in this world. And so what we can do is we can use instances. One vertex, many draw calls. All right, so we pass it in the vertex, all the vertex vertices, and then we go per vertex. We have our scene constants that we will put in every single time. So these two will always be put in, but this is way less memory than this. And then we'll just use the model constants and keep track of that. And we'll use pointers. You're not like pointers are not. We're not supposed to use those in Swift, but we're going to use them because it's really easy to keep track of the memory location. So we'll create a pointer that represents a pointer to this node array, and then we'll point at it, throw it into the GPU. Once it renders that, we'll point to the next one, and they're just model constants. This holds the matrix view, or the model view matrix. That's about all it holds right now. That's a lot less memory. It's probably like, I don't know, 16 bytes, I don't know, something, and this one's like millions. So if we loaded all of them, so let's do it that way, and let's jump into it. That was the best explanation I can give. Probably should have did more in-depth research into that, but just to talk to you about it. So first thing we're going to do, it's going to be a node. We're going to have a node. It's basically the instance is just going to be a bunch of arrays that keep track of all this stuff. So all we have to do is we have to create a node, or a node, and yeah, so yep, sorry, lost my train of thought. Here we go. So new file. We're going to call it Swift file and instances, and it's going to conform to the renderable. So we're going to import class metal kit class instance, which will be a node. Then we're going to conform to the protocol of renderables. So extension of instant renderable, and we'll have to implement some of those things. What we're going to do, like for our primitive shapes, like our cube and our triangle, they're very small vertices, so we can pass them in one by one. So the ones we really want to focus on are our models. So this will focus basically on the models. Our models will have tons of vertices that we don't want to keep track of. So, and for the most part, I don't know if you're going to be building just squares and blocks in your app. If you are, that's cool. But this, I mean, we can even come down in the future, inherit from instance and just have model or primitive or whatever. So let's do the draw. So there's that. And then this will have to have an init with a device. We just like the model, we made last week, MTL device. It will have a model name, string, image name, string, and last but not least, instance count, which will be an integer. So how many are we going to draw of this thing, and how many are we going to need to be keeping track of? And we'll be able to keep track of every single one of these on our scene. So that was easy enough. Let's go var vertex function name equals that for now. Var fragment function name string equals that. We have var, go to the top. Oh, not var, render pipeline state, var vertex descriptor. What else? Yeah, that's about it for now. That's all we need to conform at least to the renderable, and then we'll need to initialize these. So we'll do super.init right there, and then we'll go render pipeline state equals build render pipeline state. That's good. Just get that one out of the way. We'll need to create the model. So this will have to have like a main model. So var model, the one upload of the vertices that we're gonna keep track of. So model will be a model, and then we're gonna come down here and just instantiate it, just like we would before. So model equals model, and then do all these things like device, model name, and image name. So that'll generate that, and that will be what we're using for the meshes, like all the sub meshes and whatnot, just like we did before. You're still screaming at me because our vertex descriptor needs to be initialized. So we can say vertex, I think we need to do it first. Vertex descriptor equals model. We're just going to use the model's vertex descriptor because we've already defined it. Why would we make it again? So there's that. You're happy. All right. very, very happy. Sipping pre. Yet again, gotta go lift. Gotta get the job done. So we have our render pipeline state. What else? So that should be good for now. Let's go on to Google Chrome real quick because I want to show you something. So really, when drawing or when using instances, let's go here. No, let's go here. So when using instances, there's a whole entire. Just gonna go. Is there a search button? Let me see here. Hold on, data, compute. Let me see here. Okay, I'm just gonna type it in. You got this. Come on, Apple website. See if we can find some good sources on this. Instances, instance class. Draw primitives. That's what I needed. So, man, they really need like a search thing on this. This is ridiculous. Draw primitives. That's what I'm looking for. My internet's the fastest internet on this planet, as you can tell. Okay, so draw primitives. Yes. So there's this method that we use, draw primitives. You've seen it before, all over our code. And oh man, my internet is the fastest. It's so humiliating. So we have draw primitives that just renders these instances. And then we have draw index primitives. And then you'll notice that right here, or even right here with the base vertex and base instance, ignore those, but we have the instance count. So really we just have to do exactly what we did with the model when drawing, except we just need to add this one last parameter of instance count right there. And that's basically it for that. We do need to, kind of keep track of exactly what we're going to be doing, but and I'll help you with that. But yeah, so we'll need to do that. Let me think. So we are going to need two different arrays, and I'll explain about them in a second. So we're going to need var nodes, which will equal an array of node, and we'll need var, we'll call it instances, equals an array, and like I said, we're just going to be keeping track of the model constants, so that's what this will be, just an array of model constants. And then we're just going to go one by one through those, send them to the GPU, and it'll use that one vertex, one model that we pass into the GPU, and just change each, renders. I've said it enough. So we'll have nodes, instances, beautiful, and do I need anything else? I don't think so. Let me see. No. I will. Oh yeah. Yep. I'm gonna need that. So we will also need. Let me keep those right there. We will also need. So when you're using set vertex bytes like we did before with the model constants, the vertex bytes were anything less than 4 kilobytes you can send through as vertex bytes. So if you just want to send an integer through, just send it as bytes. Don't even make a vertex or a buffer, an MTL buffer. Just send it as bytes. Just send it as like pure data in its raw form. But since we don't know how many instances we're going to be drawn, and we might actually reach the cap of 4 kilobytes, we should create an index buffer and set the index buffer, or the instances buffer. So let's get that set up. So we're gonna have var instance buffer, which is an MTL buffer, and we'll need to instantiate that at some point. I forgot about that. Yep, now that's good. I think that's all we need. All right, so let's get into it. So I'm gonna write a function called create create instance. It'll be just called generate. I don't know what else to call it. Generate. That's it. That's easy. So generation, generate, func generate. So func generate. Right there. That's gonna take in instance count. Instance count as an integer. Generate. It's gonna take in instance count, which is instance count. Okay, so now basically what this is just going to do is it's going to generate, it's going to populate the nodes and the instances. It's going to populate the nodes and instances, and it's just going to go iterate over the instance count. So you write a for loop for, we can do that in 0 ... less than, because we want it to be 0 indexed to 9, less than instance count, or well, to instance count minus 1, just an array. Instance count minus 1. No, I'm just kidding. And so now we have a for loop. We can just say let node equal a new node, and then we'll say nodes.append node, and we're going to go instances.append new element, and that will be a model constant. Just like so. So now we have an array for all of our instance. We have a node. Oh yeah, I didn't explain the nodes. So the reason we're applying these nodes is we're gonna need to keep track still of, like, the node is not data. There's not all the vertices stored in the node. We don't do that by default. It only has like here, it only has the model matrix and all of these different things attached to it. So we don't actually need all the vertices on the node. So what we do is we use the node to add them in succession to the GPU, and then we just go through the nodes, apply their model matrix. Like, we needed to wait somewhere to put the these model constants and constants like that. So that's what we're doing here with the node array. And then we're also gonna utilize these instance.model constants. You'll see. Okay, so now that we've generated that, that was easy enough. Now we just need to go create the buffers. So these are the MTL, or buffer, I guess. Create buffer, right? And so this will be func create buffer, and here we'll say instance buffer equals, all we need to do is, we don't actually need to create this using any data. We just need to create a buffer long enough to hold all of the information. So because it's going to just keep changing, we're going to want to modify it using the pointer, which we'll see in a second. But for now, we're just going to go instance buffer equals, we're going to need device, MTL device, and we're going to need to go like so, device dot make buffer with length, memory, layout of, this will be model constants dot stride times, well, instance count, but since we have nodes count, we can just use nodes count, nodes.count, and then the options are just going to be like that. Très bien. All right, we need to pass in device. All right, so this is going to create the buffer for us, the instance buffer. I'm just going to call it that, instance. There we go. No, that's not right. Right there. All right. So now we have our instance buffer. Now we have all of our stuff's populated. Our vertex predictor, something, vertex function name. So in our let's do these, because we're gonna use the same fragment function, which is like the basic fragment, but we're gonna need to do a vertex function. So I'm just gonna open up over here. Cool. I'm glad I saved. But this needs to go to manual. Come on, manual. What the hell is going on here? I actually haven't used this yet, so this is I was gonna start diving into it because Swift 4 is out and I want to learn about the decoder stuff that it's got going on. We're gonna need the shaders. Okay, yes, so we're gonna use obviously the basic fragment function for now. And then we're gonna have to create another vertex function. So right here, and I'm just gonna call it instance vertex function. Right? It's gonna take stage in, and then I'll fix this all up later, but I just want this name so that we don't forget about it. Okay, draw. Oh boy, are you ready? Ready to draw? Okay. Okay. Okay, so the first thing we're gonna do is we're gonna make sure that the instance buffer is not null, right? That's what we wanna do, yep. And that'll be self.instance buffer, self.instance buffer, and we'll wanna make sure nodes.count is greater than 0. Because if it's not, we don't want to draw anything because there's nothing to draw. And else return, else return. Okay, I like to do this. Okay, next we will do everything we're kind of doing. So I'm gonna come over here and I'm gonna go to the model because the model is kind of similar to what we're doing right here now. So we're gonna need to set the model constants. Yes, so like I said, we're gonna need a pointer, and the way to do that is to utilize the instance buffer. So we can say let pointer equal instance buffer dot contents dot bind memory. So we're gonna bind the memory to model constants dot self, and the capacity is going to be nodes dot count. So we're gonna create model constants. We're gonna create so if they say the nodes.count is 10, we're gonna create 10 wide of instance buffer binding. So it's gonna bind to 10, all 10 of the because you can bind to different places. So if we have, let me go back to my patina. If we have this as the GPU and we want to bind to here and here, well, you can, or you want to bind to here, not here, and then bind to here, you can do so using this bind to. You just have to set exactly what memory you are, binding to. So, and then you can call something that's called pointer.advance by, and then you can go by 1, so it moves it forward so you're on the next data set that you want. And we're going to use that actually. So let's iterate through the nodes. Yes, node in nodes, like so. And we're gonna go pointer dot, call it the pointee, dot, and then now we have our model view matrix equals node dot model matrix, and then pointer dot pointee dot I think that's about it. Yeah, so pointer dot advance by. Now we'll just go by 1. Okay, yes, that's what we have to do. I think that's it. We don't have anything else attached to our model yet, and I thought we would, but we don't. We should probably do that. We can't say pointer dot advance by. We have to say pointer equals pointer dot advance by. And so we're going to go through every node and then just set the model view matrix, and that's what we're going to use to move all the objects around, or the models around. That is gone. Just took a drink from an empty cup. And then basically what we're going to do now is let's just do the original stuff that we did here. So we got vertex bytes. We'll need to do that. Set fragment texture. I'm not dealing with textures yet. Yeah, so let's just set the so now we can go command encoder dot set vertex bytes, vertex buffer to the instance buffer. I'm trying to think. Yes, instance buffer. offset 0, and then the instance buffer will be at 0. So this will be the main buffer. Like this is basically the, like we generated the instance buffer, and it's going to have all of that information in it. So we're going to set that instance buffer. Now we're just going to need to go through the submeshes of all the nodes to, yeah, I'm just going to stop talking. Meshes equal I said earlier we're going to use those. Let's just take this guy, because this is basically what we're doing now. Copy that. Put that right there. So now, yeah, like I said, we're doing the exact same thing now. Setting the vertex self.meshes, no model.meshes. Make sure the meshes dot count vertex buffer equals that. Oh, also, is this my, so let's go back to my model. I forgot about this. I saw this going through the code, but buffer offset, we can use vertex buffer dot offset, but we can't say dot buffer right here. So we'll do that, and then at 0, and then we'll, instead of saying vertex buffer, we say vertex dot buffer. And that's gonna work just fine. And now we're gonna do that same thing over here on the instances, right here, and submesh vertex buffer, we're just gonna get rid of this. And then this would be buffer.buffer. Okay. And then, like I said, there's only one more parameter we'll need, and that's instance count. And the instance count will be whatever the instance count is, and nodes.count. Boom. What did we not do? Oh, we didn't do this. Gotta do that. Should have did that first. So easy to forget that. No, we'll do that after, just in case we return. Argument labels. What's going on? It's not the. Oh. Who did that? Did I do that? Okay. So now that we have that set, basically doing everything we were before. We're just now doing this instance count. So we're passing in all the instances. And so what we can do is, if we create an instance, we create it with 3 things, we can just say, we can iterate, we can get the instances through, you know, like the nodes array. So we can say instances.nodes at this, or we can even write a function that says .get this guy and move him. Yeah, let me see. So we get that looks good. Let's go to our shaders too. So since now we're not taking in the reference, we're taking in a pointer. We need pointer to the model constants, and then we need just one more little tracker right here of a uint instance ID, and then that's going to have the qualifier of instance ID. Simple. Okay. Uint instance ID. Yes. And so now we can say that model constants. So model. Model constants. Model constants equals, well, you say instances at instance ID. Easy peasy. And then it's going to use the model constants dot model view matrix, and everything else is just going to work the same, because now we're taking in instances instead of we're drawing index primitives using instances. Man. right here, and so it's going to know that we're going to be passing them in instance by instance per vertex. So yes, I am going to go Command B just to build before it crashes again. Look at this, we're using the new beta. I should have been using this Xcode to begin with. That other one crashing was kind of annoying. It builds, everything looks good. Let's go ahead and go to our scene. Let's actually create a new scene because we can do that. Let's create a new scene called, we're just gonna call it like new scene, I don't know. Because our other one has kind of a lot of, you can control it a lot, and I don't want to do that, so import metal kit. I'll just copy a class over. I'm just gonna take it. I'm gonna get rid of all that input. Well, you know what? No, screw it. Sorry. We're just gonna use the basic scene. It's kind of got everything we need. I'm gonna get rid of this because we're not gonna have a movable object yet. I just want to be able to rotate stuff around. And so instead of using the movable object, just call it models. And this will be an instance. Yep, and this will be models equals instance. It'll be all of this stuff, and now we'll have an instance count, which will be, what do we want? We want like 40 of these things. Is that cool? Yeah. So now we can pass in 40 of these real easily and just iterate over them. So this will be models. Let's see, is there anything else I need to know? So I'm just gonna press play, see what happens. See if we actually get like at least a blob of these things. Let's see. By the way, I dare you to try to load 40 armadillos on your computer. Oops. Okay, so looks like we've got some stuff going awry. Let's see here. Set vertex buffer. Failed missing buffer binding at index 1 for instances at 0. What are you doing then? All right, let's go. Let's check this out. So go here. We're going to go to instances. Here we're going to go to our shaders. Model constants. Instances is at 1. I don't think I do that here. Yep. Instance buffer needs to be 1. Let's try that. Uh-oh, unused variable intensity. The text looks a little different in this version. Oh, shit. Okay, let me see. Let's zoom out. I don't know if anything's happening. Let's do the clear color. No, I don't see shiz. Alright, so we're not. Let me see here. So model constants is 1. What is this getting bound to? At 0. So set vertex buffer at 0. That's right. Because we're going to apply the vertex buffer for the node. Well, pretty sure this isn't right. Because we can't just say node.model matrix. We have to say matrix multiply of the model view matrix times the node dot model matrix. Yes. That will change the scenes. So yeah, we weren't being able to zoom out. Good. I should probably just set the instances back farther, but why didn't I do that? Okay, let's see here. Oh man, it's slow. It's not your system. It's supposed to be faster. All right. So it looks like it's loading. I'm gonna do a little clean with this memory clean thing real quick. It's gonna take a second, but yeah, in the meantime, I'm gonna do that clean and then I'll be back. Okay, so I'm back. I ran it. Appears to be just as slow as ever. Still insanely slow. I need to get a new computer. Maybe I'll, oh, it's a little faster. It's a little bit better. I bet it's the software, the capture software that's being slow. It's not the graphics. If I were to turn this off, it would be just fine. It's just the Capto, the software I use to record these, I think is making it run slow. So, yeah, let's make this, so that looks just like one, they're all put together, so let's iterate through them and put them in different spots. So if I go to my basic scene, we can just use arc for a random uniform and then set a bounds on them. So let's go for each VB, there it is again, for model in models, we can say model dot x, no, model dot position x equals arc. Where's arc? I forget what the exact term is. Maybe I should probably stop this. What's going on? Build it. Models.nodes. Right, like I said, got to use their nodes. Model.position.x equals arc for random, and we're going to use uniform with an upper bound of 5, or like 4, I guess. No, let's do like 7. Make them kind of spread out. That'll need to be a float. Don't think returns a uint32, so this will need to be just wrapped in a float. And then we're gonna say model.position.y equals float arc for random uniform. We'll go to like 4, I guess, since it's the height. It's not as tall, and we're gonna add the models. So now this is how we're manipulate each individual one. I could have done this before without doing the instances, but my computer would have blown up into a bazillion pieces, and I don't want that to happen. So let's zoom out, see where these guys are, what they're doing. See, there's all of our precious, beautiful armadillos that are still fairly close together, it looks like all on top of each other. I'm gonna spread them out a little bit more. Upper bound's gonna be 80. No, that's way too much. 20. And we'll just do 20 on both sides. So it'd be like a square. Let's see. Okay. All right. Give it a second. Give it a second. Look at that. So there's all 40 of our dudes. Well, there's 4 of them, but they're all going to be very spread out all over the place. And you can rotate the instance. You can like say instance.rotation and stuff, so you can manipulate all of them at the same time. But I promise you, this is way better than loading a million guys and using all their vertices. So we're only using their different model constants to move them around. Sorry it's so slow. It's just it's the screen capture software. I've really got to get new software. It is so bad. As you can see, like it gives me 720p on all my videos, and it runs at a ridiculous CPU. It's hard to transfer over information onto my computer when I do recording. So I'm gonna need to look into getting a new software. If you guys have any suggestions on software for recording, let me know. So yeah, that's about it for today. So I'll see you when I see you.